Hello, I'm Dr. Sam Hancock of the Emerald Planet and Emerald Planet TV. We come to you on a week-to-week basis from Washington, D.C. in the United States as we look around the globe in 144 different nations, looking for those 1,000 best practices, the technology, services, and products that are making a difference as we move through the 21st century. And as we have a planet of 9 billion people by 2038 and possibly 12 to 13 billion by the end of this century, how are we going to be able to take care of all these people on planet Earth? And that's what Emerald Planet's all about. We come to you looking at the solutions, the best practices from around the globe as we create the Emerald Planet. Hello, welcome to the Emerald Planet. We're making a difference as we move through the 21st century. And seeing the long-term impacts of climate change. We're glad to have you. Thank you for being with us. Looking around the globe, we're looking at water and oxygen. Many people don't realize that in H2O, there are various levels of concentrated oxygen in the water. And over the last number of centuries, we've been losing more and more oxygen out of the water. And so not only do we need to create new water to take care of a population that's almost at 8 billion people on planet Earth, but also we need to make sure that there's sufficient oxygen in the water that takes care of all living beings. And we have someone that's actually doing that and has been doing it for some time. This is Dr. Luke Javernick. He is the executive director, also award-winning river scientist of River Science. Luke, welcome to the Emerald Planet TV.
Thanks, Sam. It's good to be here.
We're glad to have you. Tell us the origin of River Science.
Yeah, River Science started in 2016. I was doing my postdoc, doing research, and we do a lot of different tools and research that have some really unique approaches to making data more affordable and kind of getting more data. And that was where we started. We wanted to make river data affordable to everybody. And that's where we started. And that's where we wanted our name, River Science, because there really aren't other companies like this out there, and we just wanted to make it very clear of what we were and trying to achieve.
Okay, then also I want to say that you are a 501c3 nonprofit, which is very important to many of our listeners, both here and abroad. But looking at this image about the simplicity, but also the sophistication of the data and information that you're gathering and putting out through your citizen scientists, how do you mesh those two together?
Yeah, so this picture is some of my research in New Zealand during a PhD, and that's really where we started mapping out rivers in great detail using sophisticated equipment. And in the end, you're right, like you get these beautiful, simple maps that tell us a lot of information. And that's what we're looking at here is one of those techniques that we learned. And this data is available and very applicable to a lot of projects.
Now, looking at this type of sophistication, I was at LANEC in Lisbon, Portugal, and had a chance to see many of these types of laboratories. Very simple, but yet very sophisticated in the way that they mimic what's going on in nature. So why is it important not only to be outside, as what we see here, actually in the river itself, but also to be in a sequestered location and to recreate nature in order to come up with, again, the most elegant, but the most simplistic data and information that we need?
Yeah, so this is a laboratory, a hydraulics laboratory in Italy. And that's me next to the flume, as we call it. It really is just kind of a big toy river, but in the end, it can mimic a lot of really important processes. And we use some really highly advanced mapping techniques here where we could monitor and measure exactly how rivers changed under different conditions, which, to your point, is something that would be really difficult to do in the field. Having it in this laboratory and scaling it down opens up a lot of opportunities to ask and answer specific questions, and that's kind of the balance I think you're talking about.
Right.
Is you need field data and laboratories to kind of get to these underlying processes.
Mm-hmm. Very important. Looking at it as far as the demonstrations, and again looking at nature, but also from the laboratory. There's many ways that you go about this. What are some of the things that you're talking about right here in this image?
Yeah, so this kind of back to the laboratory, this is where a lot of these techniques were refined. But we do a lot of mapping for river projects and restoration projects, where every project kind of starts with a detailed elevation map that you have to understand the ground conditions, and then to design and construct on it, or even to monitor how things are changing.
Mm-hmm.
And that's what this is showing. Is on the left there you have kind of the aerial, just the normal picture, and then on the middle of that black and white you've got all of the elevation difference of trees and houses.
Mm-hmm.
And then the third kind of gray image there removes all of those trees and buildings so that you just see the bare earth. And that's
Mm-hmm.
what's used a lot in river projects, to go through and actually understand the conditions, and then figure out what's happening, and also to design improvements on top of that.
Right.
And this is one of the technologies. So this is just a different view of it. This is the end product is called a digital elevation model, or DEM. And you can kind of see there the colors. The red is higher elevations, the yellows and greens are lower elevations. And in there you can really see like where ridges are and buildings, and you can see the river channels very clearly in there. And that's always, having this kind of data available is really important in our industry.
Now, looking at the drones, this is something that's being used globally. Many different configurations, many different styles. You can see this is outfitted with the camera and video camera. Why are drones so important in today's scientific research, but specifically as it relates to water?
Yeah, that's a good question. Well, it kind of goes back to data being expensive, and drones are very cost effective, and you can go out and immediately get the data that you're looking for, if you know how to fly them properly and collect data properly with them. But it's one of the great revolutions in our industry, is the ability to go out and quickly capture the data we need, and to do it cost effectively, and drones are a great tool for that.
And the whole thing about having the drone too, it keeps from having the danger to the humans that may have to go into areas that are inhospitable to human life, and at the same time be able to fly low and to collect that data and the image. And I assume this directly relates to the drone.
Yeah, so this is a video, if it plays. It shows how we use the drone in the field to go out and collect these full maps, these beautiful 3D elevation models. And this kind of shows the beginning here, where it initially starts to build together the points. And then it shows the individual camera images with the blue rectangles. And then eventually this video shows the full 3D rendering of this creek. And this is, it's really beautiful and interesting, but at the same time, there's a lot of ways that we process this data out to do our work, and it's extremely cost effective compared to other solutions.
Right. Now, this is very interesting as far as water quality. Tell us what we're looking at here, because we're looking at different low-cost implements that are used to do the analysis that you need on the water quality, and also the quantity of it as well. So what is this machine all about?
So in addition to a lot of the mapping and elevation surveys that we do, water quality is a challenging field, because one, water quality data is really expensive, because you have people going out into the field collecting it, which is expensive. The travel is expensive. Sometimes you have to take samples and send it to a laboratory to have analyzed. That's expensive. And all of that expense makes it to where you can't get data very frequently. Mm-hmm. And so we've built our own water quality instruments, like this one shown. This is one of our, I think this is version 2 prototype here. It's got 6 sensors, solar, and then it has GPS as well. And so the whole idea is to be able to make this data affordable so that we can get more data and start to see how these river environments are changing over time. Yeah.
And one of the interesting things about this urban to remote locations, this is something very important because more and more the Earth's population is becoming concentrated in the cities. And in many countries, the rural areas are literally being left behind, but yet the cities can't survive without the rural areas. So the fact that you're ahead of this as far as having the types of techniques and technologies where you can find out what's actually going on in these very remote rural areas, and then what may be coming next for the urban areas, I find very interesting, Luke. And thank you for sharing this with us. Tell us what this gadget's doing here.
This is just another one of those units that's actually out in the field collecting water quality data on this little stream before it goes into the Arkansas River down there. And it's sending out data to the cloud every 15 minutes of these different water quality parameters. And just to what you're talking about, we're monitoring these smaller systems before they get into the bigger ones, so we can kind of pinpoint where problems start to occur and when, and then we can backtrack and figure out with more of these sensors out where the problem started.
Mm-hmm, mm-hmm. Now, looking at this is a very sophisticated system we have here. We're making it simplistic, but how is this actually working, and why is this data so important?
Yeah, so this is just a good example of kind of how our technologies are a little bit different. So for that mapping, we go out and we use drones and some land survey. And the other technology that's widely used, and it's good data as well, but it's called LiDAR, and it goes out and uses larger aircraft and lasers that scan the ground. And that's just a point to kind of make between ours is, this data has a lot of overhead. Big airplanes, the lasers can cost millions of dollars. And I just wanted to highlight how we're different and why some of our stuff, when I say cost effective, it's why, and it's just a lot to do with the overhead. Now, just quickly, sometimes LiDAR is the much better way to go because with a big plane, you can fly big distances. And so there's that sweet spot of where we're more affordable and where LiDAR becomes more affordable, just to be clear.
It just goes to show that we need to have as much sophistication and equipment as possible to do whatever is needed. I really like this image, and we're just about running out of time. But why is it so important that you have to really sometimes just be there and to be in the middle of nature to really know what's going on?
Yeah, so technology can't do everything right now. This is 2 people out in the field collecting water quality samples and getting ready to do some chemistry and then probably send it off to a lab. And it's just, technology isn't quite there for everything, particularly metals, and that's still needed.
Mm-hmm, mm-hmm. Looking at it, we have about 30 seconds left and we have to be quick. What do you see for the expansion for the next 5, 10, or 15 years of this very simplistic way of getting very sophisticated data and information?
Yeah, there's just so much technology coming out, and everything's getting better and the cost is coming down, and we're just going to get to a point where we can have more and more data. We just need to be able to use that data effectively, and that's where we're trying to be in river science, is trying to make sure that we're helping other organizations along to understand and use this to the best ability.
That's absolutely fantastic. This is Dr. Luke Javernick. He's Executive Director, award-winning river scientist of River Science. Thank you for being with us as we create the Emerald Planet.
Thanks, Sam.